Imagine living in a world where everything is decimal. 10 fingers on hands, 10 digits, metric system based on tens. Logical, simple, elegant. And then, we look at the clock. 24 hours a day, 60 minutes per hour, 60 seconds per minute, 365 days a year. But why not 10 hours a day? Why not 100 minutes per hour? Where do these strange, seemingly random numbers come from? Welcome to the Cognitive Channel. The answer to this question will take us on a journey through 5,000 years of history. 3 continents and various ancient civilizations that tried to tame something intangible, the very passage of time. At first, there were no clocks. There was only the rhythm of nature. The sun rises, the sun sets. That was a day. The moon goes through its phases. That was a month. The seasons repeat. That was a year. For our ancestors, that was enough. They didn't need to know what time it was. They needed to know when to plant, when to harvest, when to migrate following the home. But when people started to create civilizations, build cities, organize societies, they needed something more. They needed a way to divide time into smaller parts. To synchronize actions. To plan, they needed a calendar. And clocks. And different civilizations solved this problem in different and fascinating ways. Let's start with the year. Why exactly 365 days? The ancient Egyptians were among the first to notice that the Nile flooded once every 365 days or so. And that coincided exactly with the moment when the star Sirius appeared in the sky just before dawn. It wasn't an arbitrary decision. It was a rhythm imposed by the planet itself. The Earth orbits the Sun in a time that lasts exactly 365 days, 5 hours, 48 minutes, and 46 seconds. The Egyptians rounded it to 365 days. They divided the year into 12 months of 30 days each, which gives 360, plus 5 extra days at the end of the year, they called days out of time. But here, a problem arises. Those almost 6 extra hours a year accumulate. After 4 years, it's already a full day. The calendar starts to desynchronize with reality. Julius Caesar, in 46 BC, was fed up with that chaos. The Roman calendar was so out of sync with the seasons that no one really knew what month it was. He introduced a leap year. Every 4 years, an extra day in February. That was supposed to compensate for those almost 6 extra hours a year. But even that wasn't perfect, because the year doesn't last exactly 365 days and 6 hours. Those 11 minutes and 14 seconds are still missing. It sounds small, but over centuries, it accumulates. By the 16th century, the Julian calendar had desynchronized from reality by 10 days. Spring theoretically started on March 21st, but astronomically, it already started on March 11. Pope Gregory XIII, in 1582, ordered a radical reform. 10 days were removed from the calendar. People went to sleep on October 4 and woke up on October 15. And more complicated rules for the leap year were introduced. It was the Gregorian calendar, which we use to this day. But where do the 24 hours in a day come from? And why 60 minutes per hour? Here we have to go back even further. To the Sumerians and Babylonians of ancient Mesopotamia, about 5,000 years ago. These people did not use the decimal system like us. They used the sexagesimal system, based on the number 60. Why 60? Because 60 is a magic number. It can be divided by 1, 2, 3, 4, 5, 10, 12, 15, 20, 30, 12 distinct divisors. For comparison, 10 has only 4 divisors. That made 60 an extremely practical base for commercial, astronomical, and engineering calculations. You can easily divide it into thirds, quarters, fifths, sixths, without decimal fractions. And precisely, the Babylonians, brilliant astronomers, were the first to divide the day and the circle into 360 degrees and the hour angle into 60 parts. But why 24 hours and not, let's say, 60? The ancient Egyptians divided the day into 12 parts and the night into 12 parts. Why 12? Because they observed 10 constellations passing through the night sky, plus 1 hour for twilight and another for dawn. 12 is also a number that appears in nature. 12 lunar cycles a year. 12 zodiac signs. And like 60, 12 has many divisors. It can be divided by 2, 3, 4, and 6. The problem was that Egyptian hours did not have the same duration. Daytime hours in summer were longer than in winter, because the day was longer, the same with nighttime hours. Only the Greeks introduced the idea of equinoctial hours, hours of constant length based on the equinoxes, when day and night have equal length. And so, we got 24 hours of equal length. But how were those hours measured before mechanical clocks were invented? The oldest method was sundials. A simple stick, stuck in the ground, cast a shadow that moved during the day. Divide the circle into 12 parts, and you have a clock. But they have an obvious problem. They don't work at night, and they don't work on cloudy days. The Egyptians invented clepsydras, water clocks. Water dripped from one container to another at a constant rate. Marks showed how much time had passed. The Chinese went further, creating complicated mechanical water clocks with gears and bells. But all were inaccurate. Water flows faster when it's hot, slower when it's cold. Pressure changes. The containers are not perfectly smooth. The real revolution came in the Middle Ages, when the mechanical clock with pendulum was invented. And the division of the hour into 60 minutes and the minute into 60 seconds is a direct inheritance from the Babylonians, when medieval astronomers began to measure time more accurately. They needed smaller units than the hour. They called the first subdivision the first small division of the hour, minute, from Latin pars minuta prima, first small part dot. And the next subdivision they called second, from pars minuta secunda, second small part. And like the Babylonians thousands of years before, they used the sexagesimal system. 60 minutes per hour, 60 seconds per minute. It's funny that a system invented by people who counted on clay tablets 5,000 years ago still determines how we measure time in the era of atomic clocks and quantum computers. It's like archaeology embedded in the very way we perceive the passage of time. But does it have to be this way? Couldn't we create a more logical system to measure time? It has been attempted several times. The most ambitious attempt was the French Revolutionary Calendar of 1793. The revolutionaries wanted to break with everything that reminded them of the old order. So they created a new calendar. 10 days a week, 3 weeks a month, 12 months a year, 10 hours a day, 100 minutes an hour, 100 seconds a minute. All beautifully decimal. Logical, rational, and completely impractical. People couldn't adapt. Clocks had to be replaced. The whole society functioned based on the old system. And besides, nature is not decimal. The year does not have 365 days because someone decided it, but because that's how long it takes the Earth to orbit the Sun. The revolutionary calendar survived barely 12 years before Napoleon discarded it. Today we measure time with a precision that the ancients could not even dream of. Cesium atomic clocks measure time based on oscillations of cesium atoms. 9,190 and 2,600.317 oscillations are exactly 1 second. It is so precise that the best atomic clocks in the world would be off by 1 second only after 300 million years. But even these supermodern devices use the old definition of a second. The second derived from dividing the hour into 60 parts. The hour derived from dividing the day into 24 parts. The system invented by people who observe stars with the naked eye. It's like building the International Space Station using units invented by the ancient Egyptians. And it works. Because time is not just physics. It is also culture, history, tradition. But there is a problem. The Earth is not a perfect clock. Its rotation is gradually slowing down. Mainly due to the tides caused by the moon. Every century the day lengthens by about 1.7 milliseconds. It sounds little, but over the years it accumulates. And from time to time, we have to add a leap second, an extra second at the end of the year, to synchronize our atomic clocks with the Earth's rotation. The last leap second was added in 2016. At midnight on New Year's Eve, the clock struck 23, 59, and 60 seconds. And only then did they jump to 0, 0, 0, 0. This creates chaos in computer systems. Programmers have to consider the possibility that a minute sometimes lasts 61 seconds. Some propose to eliminate leap seconds altogether and let atomic time drift away from solar time. Because perhaps the time measured by cesium atoms is more real than the time measured by the planet's rotation. And it is worth remembering that our system is not the only way to measure time. Different cultures invented different solutions. The Islamic calendar is purely lunar. 12 lunar months, resulting in a year of 354 or 355 days. That means Islamic holidays move through the seasons. Ramadan can fall in summer or winter. The Hebrew calendar is lunisolar. It tries to reconcile lunar cycles with the solar year, adding an extra month every few years. The Chinese calendar is also lunisolar, but with its own complex system of year nomenclature, based on a 60-year cycle. The Mayan calendar used several concurrent systems at once. The short Tzolk'in, of 260 days. The Hab, of 365 days. And the long count, which counted days from a mythical beginning of the world. Each of these systems was adapted to the needs and observations of a specific culture. And the modern world added its own complications. Time zones, introduced only in the 19th century by railroads that needed synchronized schedules. Daylight saving time, which forces us every year to move the clocks forward or back an hour. An idea created during World War I to save energy. And now mainly annoying and possibly harmful to health. And the global coordination problem. When it is noon in New York, it is midnight in Tokyo. International companies have to juggle time zones, organizing meetings that for someone will always be at an inhumane hour. And astronomers use universal time, UTC, the time at the zero meridian in Greenwich, as a standard, ignoring local solar time. Time has ceased to be something natural and local. It has become a global convention that we negotiate socially. But that leads to a deeper question. Does time even exist? Physicists have debated this for centuries. For Newton, time was absolute. It flowed uniformly, regardless of anything. A universal clock, according to which the universe operated. Einstein proved that this is not true. Time is relative. It flows slower when you move fast, or are in a strong gravitational field. There is no universal now. Different observers do not agree on which events are simultaneous. And some philosophers and physicists go further. Perhaps time does not flow at all? Perhaps past, present, and future exist simultaneously, and we only perceive reality sequentially. Perhaps all our hours, minutes, and seconds are just the way the human mind organizes the experience of change. It is not time that flows, but we who change. The future of time measurement will be even more precise. New optical atomic clocks are already 1,000 times more precise than cesium ones. Geodesists can detect the difference in the passage of time between two altitudes that differ by 1 centimeter. It sounds like science fiction, but it has practical applications. Geodesists can use atomic clocks to measure the shape of the Earth. They can detect tectonic movements, changes in the gravitational field, perhaps even gravitational waves. And perhaps one day, we will define the second, not by oscillations of cesium atoms, but by some even more fundamental physical constant. Perhaps by the quantum vacuum oscillation period. Perhaps by the time it takes a photon to travel the Planck length. The more precisely we measure time, the closer we get to fundamental questions about the nature of reality. So why does the year have 365 days, the day 24 hours, and the hour 60 minutes? Because the Earth orbits the Sun at that specific rate. Because the ancient Egyptians noticed that 12 is a convenient number to divide the day. Because the Babylonians loved the number 60. Because medieval monks needed to measure prayer times. Because railroads needed synchronization. It is a mix of astronomy, mathematics, historical coincidence, and human need to organize chaos. Our way of measuring time is layer upon layer of random decisions, cultural conventions, and practical compromises accumulated over thousands of years. And every time you look at the clock, you see an artifact of that history. You see the Sumerians counting on clay tablets, the Egyptians observing the stars, Julius Caesar reforming the calendar, medieval monks dividing hours into minutes. Time is not natural. Time is an invention, perhaps the most successful invention of humanity, because it allows us to cooperate, plan, remember. It unites us across space and time. If you made it to the end, thank you very much. Leave your mark in the comments and tell us what you think. Remember, science never ends. Until the next episode.